daily talk we have to have. You're not going to the hospital.
So it's creepy?
It's creepy that...
You know, we're obsessed with different answers.
Yes, it's a little creepy.
It's creepy that Sarah asked what you were wearing.
I know.
Yeah, that's
When I'm on my maternity leave, I'm just going to text Mr. Pruitt a picture of me every now and again so that he can show Sarah what I'm wearing.
I'll be like, oh, that's nice.
Maybe I shouldn't do that. I'll email it. That'll be less creepy, maybe?
No, I
That's like Craigslist.
Oh. I don't think he'll appreciate it. Okay, today we're going to talk about slope fields, and maybe, Matthew Hunt, put your book away! Oh my goodness. Maybe you saw some cool pictures in your homework yesterday of some slope fields. But basically, remember that a derivative is a slope. So we can look at every point on a graph and say, what is the slope at that specific point? So that's what this says, right? Let me get Matt his other part of his test. Oh my goodness. There you go. Just kidding. So today we're going to approximate the solution not by doing the integral, not by doing really any calculus, but by graphing little slope lines. Doesn't that sound exciting? So I printed these out for you, not because I love you, but because I didn't want to make you have to draw this, right? I'll save that for your homework.
If not, you wouldn't let us go over the
You're not going. My mom doesn't even get to go.
What?
We can fill in for her.
Yeah.
After I have the baby, she can come in.
We'll take turns.
But no.
You're gonna go in while you're delivering.
Well, that's what it sounds like. That's what it sounds like. Like, we're going to the hospital with you. When you have the baby, we're going to be right there cheering you on.
But I just go like, yeah, with her little full finger.
It's a little creepy.
We're like, find the derivative, you can do it, or something. I don't know.
So we're going to start off really, really simple here to get an idea here. But a slope field means this is saying the slope of this function is 1. Yes? That's another way of saying the derivative is 1. Do you agree that this is saying at every point, so no matter what I pick, I can say like x, y, and then we're going to say dy dx. Making like a little x, y, dy dx chart. At the point 0, 0, what is the slope of this graph? 1. Like I said, I picked a super easy one. Do you agree no matter what point I pick here, like at the point 2, 2, what's the slope of this one going to be? Still 1 because it's just 1. It's a constant slope. So we can show that on this graph by drawing a little line segment with the slope of 1. What does a line with a slope of 1 look like? I always like to imagine drawing an actual line. Like at 0, 0, if I wanted to draw in a slope of 1, if I drew in the whole line, you don't draw this. It would go like all the way through there, right? Because that would be like up 1 over 1. But for a slope field, we're just going to draw a little bitty line segment. So when I do this, I just kind of imagine drawing in, what would it look like, and I just draw in that one little segment. And that means at 0, 0, I know the slope is 1. Could I do that at every point? Like at this point up here, I could imagine drawing in a slope of 1 over 1, or imagine connecting this point to this point, and it would kind of look like that as well. It's like art class today. And could I do this for every single point on this graph? At this one, be like up 1 over 1, and it would also look the same slantedness, because it has the same slope or the same derivative. And here, and here. And I'm just going to keep going. And here, and here.
So are you on all those or just one?
Every single one. Every single point that has a dot on it, we're going to make a slope of 1 on it.
Why don't we just draw a line and erase it?
Because we're not. Well, I mean, I guess you could, since they're all the same. Isn't this fun?
Let me tell you.
Oh, that one's a terrible one. Roughly speaking, yes. This stop being highlighted. Parker keeps saying he wants 10 kids now. He's like, I want to have 10 babies. And I was like, you're crazy. And last night he said, why can't we have more kids? And I said, why don't you wait till this one gets here and see how much fun it is before you decide that you want to have another one. Okay, what is the point of this? Well, now we can sketch in a curve if they give us a point. Just like we can take the integral and we can give an exact equation if they give us a point. It says sketch the curve that would pass through the point 0, -1. So go to that point on your graph, 0, -1. You agree that would be the point like this? We can use the slopes to help us. And again, I started really basic here. But if it goes through 0, -1, that means it's going to have a slope of 1. And I know that it's going to always have a slope of 1. So could I draw in the exact equation for this solution? And it would be that line right there. Could we have just found the integral of this and plugged that point in and found the equation? Yes. But they're not going to all be this simple. And so this is another way that we can solve differential equations, and then we can approximate curves. In the last 12 years of the AP exam, I believe 8 of the 12 years, there has been a slope field question on one of the free response questions. The first couple years that it was on there, this never used to be in the textbook. So this is kind of a pretty new topic in high school calculus, but now everyone teaches it because it was on the AP exam so much. And then the last few years, it hasn't been on there as much, but there definitely would be a question or two that you could expect, maybe on the multiple choice, maybe on the free response. I think we should do a harder one. Yes?
Wait, so we always have to draw in all those little...
For every point that's on this graph, you're going to draw a slope in, which is so much fun. So I believe on the AP test, they always give you this little graph, or however big they want you to do it. On your homework, it says, like, draw in for, like, -2 to 2, or -1 to 1, so you know how many points you have to make. Because, right, this is only going to, like, 2, -2 to 2. It's not like -10 to 10, that would be crazy. It takes long enough to do this one. So let's step it up one more level of difficulty here. XY, dy dx. And basically what this chart is doing is saying for every point on that graph, could I figure out what the slope is? Unlike the last one, do you agree the slope's going to change on this one? And it's going to change when the y changes, right? Because there's no x in this problem. But I could just pick, like if I plugged in 0, 0 into this problem, what am I going to get as my slope? What if I plugged in 1, 0? Could I jump to the conclusion to say whenever y is 0, the slope's going to be 0 without having to write every point down because there's no x in the problem? So where on my graph is y always 0? The x-axis. So I know that on the x-axis, my slope is 0. How do we draw a line of a slope of 0? Straight across. So we could say that at all of these points, it has a slope of 0. What about if I picked like 0, 1? up 1 and up here, 2 times 1 means it would have a slope of 2. Could I go ahead and say, I can do one more here, 1, 1. Y is still 1, so it's still going to be 2. When y is 1, which would be this whole column, row, do you agree that the slope is always going to be 2? How's a slope of 2 going to compare to a slope of 1 that we graphed last time? It's going to be steeper. And so that's the big thing that I'm looking for on this, and that's the big thing that AP people are looking for. It's okay if it's a little bit off, but if you have a slope of 1 on this graph as well, a slope of 2 better be steeper than a slope of 1. I always imagine actually drawing in a slope of 2. Like if I drew in a slope of 2, what would I connect? Like if I go down 2, back 1, would that be like connecting this line to this line? That's how I visualize it. I struggle just being able to sketch it automatically. If you want, with a pencil, you could actually connect those two to get an idea of what it would be. I tend to just wing it, which probably isn't the best idea, because I feel like that still looks like a slope of 1. Alright, maybe I'll try to draw it in. And then once you get the idea of how steep it is, you can just draw the other ones in with it. Right? Like we want them all to sort of be the same. I'm terrible at this, kids. Kind of. Maybe. What's going to happen when y is 2? So this whole one is going to be a slope of 4. How's the slope of 4 going to compare to a slope of 2? Even steeper, right? Think about, again, I always pick a point. If I pick this one, I'm going to go down 4, back 1. That would be like connecting this point to this point down here. It's going to be a really steep line. It's almost, I mean, not quite, but it's going to be almost straight up, right? Can I cheat a little bit so maybe I can have some hope that this will be right? Okay, so then I can go like this and trace that. That for some cheating. Totally cheating. Again, what you're wanting to look for when you're looking at this is that they're getting steeper. It's 0, it's a little bit steeper, even steeper. What's going to happen down here? Because it's going to be negative, right? At -1, we're going to have a slope of -2, so it's going to be just like this, only it's going to be negative. I'm going to go with my new cheating method here. And the same thing with at -2 is going to be -4. Do you agree with that? So that's going to be like super steep like this. Some leeway in that, right? On the AP test, on the free response, they always give you 1 point for graphing the 0 or undefined slope correctly, and then 1 point for all the other slopes, which means they're going to be pretty lenient there, especially as long as you have the positive negative right, and it looks somewhat alright. This is an example of one that wouldn't be that easy to solve, because there's a y over there. We'd have to move the y to the dy side. I think this would end up being an ln graph if we actually tried to solve it. But that would be the solution there. It's pretty much what you're doing your homework today, is drawing these out. It's so much fun. Let's do another one. about you get a head start on this one? What's going to determine your slope on this one? X, right? So the y, because there's no y over there, you really only have to look at the x and see what's changing. Sometimes there might be an x and a y in it, and those are the ones that take a lot of time. Part A, where part B, part C, part D is extra credit, so you don't do it. And there's one more question here, part A, part B, part C, and you do have a graph mechanism you have here. Oh man, this is 1, 2, 2, 3, negative 1, 0, and negative 2, 1. Right? Again, you're trying to show the steepness there a little bit of them getting steeper than the other ones. Definitely make sure you make your positive or negative slopes correctly. 0 is my favorite slope. So when x is negative 1, the slope is 0. That would be this one, right? And remember, x's go up and down, so we're going up and down this time, right? Where you guys are going side to side. When x is 0, that would be the y-axis. Your slope is 1, so that would be like this. When x is 1, your slope is 2, so it's getting steeper. And when x is 2, my slope is 3. And again, if you notice, I kind of get lazier as I go along. What you're wanting to show is that it's getting steeper as it goes. So this is a slope of 1, and then 2, and then 3. So I can see by looking at this that the slope is getting bigger or steeper over time. It's positive slope. And then when x is negative 2, my slope is negative 1, which would be like up 1, back 1, which would be like going like this. Somewhat, roughly, maybe. Very roughly. Tomorrow we're going to focus on the other type of this. Today you're going to do a lot of drawing these yourself. Tomorrow we're going to focus on what if I gave you some of these and I asked you to match them up with its differential equation, or match it up with the original equation, and how we go backwards from that, because that's kind of what we see on the multiple choice sometimes. Sketch the curve passing through the point -1, 0. So this means at -1, 0, that would be here, right? Let's think about this in terms of the slopes for a minute. Wait a minute, are you done drawing these or not? What happened? That's -1, 1, isn't it? Thanks, just kidding. I really do know what I'm doing sometimes. -1, 0. Can't wait till you watch my videos and I make mistakes and you can't stop me. Hopefully I notice them myself eventually is the part I hope for. I want you to try to start thinking about this in terms of the slopes and not the equation, but we definitely can use the equation to help us. But if this is a slope of 0, what do we know about this point on my graph? It's a max or a min, right? Because a slope of 0 is where your derivative equals 0, a max or a min. So JD says it's a minimum, maybe because he's looking at the slopes around it. If this slope is negative on this side and positive on this side, do you agree with JD that that's going to be a minimum? And we can use the slopes to help us sketch this graph in. It is definitely a sketch, but do you agree that I could say these slopes, like it's going up, it has a slope of 1, and then it's just going to keep getting steeper and steeper? And this side has a negative slope, it's going to be a slope of 1, and it's just going to keep getting steeper and steeper, which means I could kind of sketch this in. It's not necessarily going to go through these specific points, but that's going to be a parabola when I sketch that in. How could you make sure of that? Think about if we took the integral of this. If this is x, and we went backwards, wouldn't that become x squared? Yeah. So that's an idea, another way that you can solve differential equations using a slope field and then sketching the curve in. So on your homework today, I'm pretty sure that's what you're doing. You are sketching slope fields and then sketching a curve. Some are going to be harder than others, especially some that have both x and y in them. It is a little time consuming because you do have to make some slope fields. Questions about that? I think that's it. I have such short notes. This is 6-1 day 2. I really do have an assignment sheet for you today. 29 through 32. Let's look at those really quick. 29 through 32. Those are make a slope field, and they give you what they want you to do. Like it's from -1 to 1 on the x-axis and from -1 to 2 on the y-axis. So those are the only points you have to make. I would recommend, if it was me in my paper, I would draw in the little dot paper in pen, and then sketch your slope in pencil, so that if you make a mistake, you could erase it without erasing your dot. But it's your choice there. And then 35 through 40, you're gonna match. They gave you the slope field, and you're going to match it with the equation, and we'll see how we do with that. And then the same thing, 51, 52, 61. Those are the only ones there. So you have 4 of these that you're actually drawing, 29 through 32.